first thing we need to do in Cubase after installation is to set up the audio and MIDI functionality. This can be done under the Devices menu and then pick Device Setup. To the left, you can see the devices that are in Cubase. For this chapter, we're only concerned with this one, MIDI. Under MIDI, we have MIDI Port Setup. You can see all the MIDI ports attached to your computer. The ins and outs are color-coded so that you can recognize them more easily. Choose the ones you wish to use by selecting them in the visible column. When you get rid of the X, it makes the MIDI port invisible within Cubase. You might want this because there could be a lot of MIDI ports on your computer, but you're only using a couple of them, and therefore you only want to see a couple of them. Setting a MIDI port to invisible doesn't mean the port is disabled, only invisible. If I set this port to invisible, but turn on the In All MIDI Inputs, the MIDI port will still work. We just won't see it in the list of available inputs. The port system name is the name the computer gives the MIDI port. Show As is where you can rename the port to anything you like. This device's name is too long, so let's rename it. Feel free to rename your devices to names you are more likely to recognize. Since this keyboard is just a controller keyboard with no onboard sounds, we don't need Cubase to show it as an output. On the right here, we have In All MIDI Inputs. Instead of choosing a MIDI input for all of your MIDI tracks, you can have all MIDI inputs chosen as your MIDI input. This makes things quicker, especially if you have a lot of different inputs and want any one of them to be able to send MIDI data to your MIDI track. You have a choice whether a certain input will be in the All Inputs list. This is good if there is a MIDI input you are using that only receives MIDI clock or remote controller information. In this case, you won't want to have these in your All MIDI Inputs. Generally, you'll leave your MIDI input on a track set to All MIDI Inputs, saving you time and keeping the musical flow moving. The State column lets you know if the ins and outs are being used or not in the current Cubase project. These two options down here are only available on PC computers. If you feel that your MIDI timing is off, you can check these options. Using System Timestamp allows for better MIDI precision. If you're unsure about which system timestamp to use, look over here and you will see the specifics of your device. The Reset button returns all of the MIDI ports back to their default names and makes them all visible again. Well, that's it for MIDI setup. If you're used to earlier versions of Cubase, you'll notice that in Cubase 6, things have been streamlined and simplified yet again. Move on to the next chapter to set up your audio hardware. We're continuing from the MIDI setup chapter and moving on to audio setup. Make sure that you are in the Device Setup window by selecting Device Setup under the Devices menu. Clicking on VST Audio System, we can choose our audio driver. Whether you are on the Mac or the PC, the best choice is the ASIO or ASIO driver for your audio card. ASIO stands for Audio Stream Input Output and is a digital audio protocol designed by Steinberg. And since Steinberg invented Cubase, it would be the logical driver choice for stability and speed when using their software. If the audio card you're using does not have an ASIO driver, you can use the DirectX or Multimedia driver on the PC or Core Audio on the Mac. Once the driver is picked, you can choose whether or not Cubase will release the audio driver when Cubase is not the program in the foreground. Let's say we had two audio programs that were sharing the same audio driver. We could set each of them releasing the audio driver in the background so that when a program is the chosen front one, that's the program that has access to the audio driver. You'll find that some audio drivers can do this very easily and some are very unforgiving. You'll also find that some audio programs will not let go of the audio driver. Experiment to see if your audio driver or other audio programs are capable of this. If you are concerned at all with stability, leave this unchecked. This section tells me the total input and output latency. Latency is the time between the moment when Cubase sends out the data and when it actually reaches the output. The latency is usually set by an external software control panel that comes with your audio card. We'll take a look at that in a second. Just below that, we have the sample rate the audio card is set to. The higher the sample rate, the lower the latency. However, many people leave the sample rate set at 44.1 for convenience sake. There are some extra items in the Advanced Options section of the window that you can read up on by pressing Help here. Everything is well explained. Almost 99% of the time, you won't even need to change any of these options. I will, however, give you some helpful hints right now. If you ever mess up these settings, rest assured that you can set the parameters below back to their default values by pressing Reset on the lower right. When you run Cubase, there are several processes fighting for access to processor time in your computer. The audio priority parameter allows you to determine how much priority is given to the audio in Cubase. If normal is set, MIDI timing, screen updates, and audio get equal priority. Boost gives maximum priority to the audio. Great if you're using a lot of audio effects and EQ and not much MIDI. Multiprocessing is only available if there's more than one CPU in the computer. If activated, Cubase will automatically distribute the processing evenly between all CPUs for optimum performance. Speaking of computer processing power, the Steinberg Audio Power Scheme is a new feature of Cubase 6 for users of the Windows operating system. The Steinberg Audio Power Scheme optimizes Windows power handling to deliver the best possible audio performance at low latency ASIO buffer settings. However, this also increases the power consumption of the computer. If power consumption is a concern, such as with a laptop, disable this option and increase the buffer size of your audio hardware. Disk preload is the amount of audio data that is loaded into RAM prior to starting playback. The purpose of this is to ensure smooth playback. Try different settings only if you're experiencing problems. If your audio hardware reports an incorrect input latency value or your system has a high output latency while recording through plugins, you may experience that the audio material you've recorded ends up in a displaced position, either too late or too early. You can compensate for this by adjusting these two parameters. By deactivating Adjust for Record Latency, you instruct Cubase not to use its plugin delay compensation feature. If in doubt, leave this checked, as this is one of the best features of Cubase, leaving you with one less thing to worry about. If you change the record shift value, the position of recorded audio will automatically be shifted by the corresponding number of samples. Positive values shift the position forward, and negative values shift the position backward. All of this can seem very confusing, but remember that if you change any of these settings and things get worse, you can reset these features by pressing Set to Defaults. Since we chose the audio driver here, the name now appears below VST Audio System over here. Let's click on it. If you've made changes in the VST Audio System, Cubase may ask you to apply them now. This looks similar to the MIDI port setup we saw earlier. It lists our audio ins and outs by colors. We can change their name here and decide if we want them to be visible throughout the program here. If we never use certain ins and outs, you may as well make them invisible. The state column lets you know if the ins and outs are being used or not in the current project. A reason you might want to deactivate inputs and outputs is to make your life easier. Let's say you are only ever going to use the first two inputs of your sound card. You could turn off all the other inputs. Or, if you're only ever going to use the first four outputs, but you have extra outputs like ADAT and SPDIF that you never use, you can deactivate them. What is available under clock source depends on your audio hardware. There could be options like internal, which would typically refer to the clock in the installed audio hardware, and external or digital, which would typically refer to the clock of another digitally connected audio device. I have the word settings here, which informs us that we can change these in the control panel of the audio card. There is also the possibility that nothing is displayed here, or that it is set to internal and won't let me change it. In this case, you may be able to change it in the control panel above. Clicking on Control Panel will call up the audio control panel of the audio hardware you are using. Depending on your audio hardware, there might not be a control panel. This panel is exclusive to my audio card. You will have a different one for your audio card. For this audio card, you can set the latency by clicking here. Let's change the latency. Notice that the change in latency is updated immediately on the VST Audio System page on the right. If the latency on your audio card is higher than 6 milliseconds, you may need to turn on direct monitoring. This is because anything higher than 6 milliseconds is very noticeable to our ears. The combined input and output latency of 12 milliseconds or higher appears as an echo to us, while combined latencies of less than 11 milliseconds are perceived as a chorus and will therefore not affect our performance timing. Turning on direct monitoring allows the audio to come into your sound card and right back out so there is no delay. Otherwise, the audio goes into your sound card, gets processed through Cubase's mixer, EQ, and effects, and then gets sent out. If your computer and audio hardware isn't fast or powerful enough to process it quickly enough, you'll get a delay. Some audio cards have this option grayed out. It is most likely that the audio card's control panel has direct monitoring built into the physical interface of the card. VST System Link will be explained in Level 4 of this tutorial series, so we'll skip this for now. And that's it for audio setup. We'll look at assigning different ins and outs when we get to the section on recording audio.